Today I will say calculus of variation. In my previous video I have seen what is the calculus of variation. Also I have seen Euler equation to find the extremal. Today's goal of this lecture, today I will see some example on this Euler equation. Also I will see some extra case and I will see some example on this case. Case 1, when f of xy is independent of y prime. When f of xy is independent y prime, that means that imply obviously del f del y prime equal to 0. And since del f del y prime equal to 0, that means from Euler equation we can write del f del y equal to 0. And since del f del y equal to 0, that means f with respect to y at the point xy equal to 0. And case 2, when f is free from y. Since here free from y, that means obviously del f del y equal to 0 from Euler equation we can get. That means that imply ddx of del f del y prime equal to 0. Del f del y prime equal to 0. And from this equation it imply del f del y prime equal to constant c. Now I will see some example based on this theorem, because this type of concept actually very important for any competitive exam. Find the extremal of the functional I yx equal to integration half to 1 x square y prime whole square dx. And here the condition y half equal to 1 and y1 equal to 2. Notice here f of x comma y prime equal to x square y prime whole square. Since this equation is free from y, therefore by Euler equation ddx of del f del y prime equal to 0. That means ddx of x square to y prime equal to 0. That imply obviously x square to y prime equal to constant c. That imply x square dy dx equal to c over 2. And since c over 2 be a constant number, so consider this is be a c1. That means this is c1 new constant number. That means that imply x square dy dx equal to c1. And now write this is dy and here c1 dx over x square. Now integrate both sides. Then this would be y equal to c1 x to the power minus 2 dx integration x to the power minus 2 dx, and the value of the integration would be x to the power minus 2 plus 1 over minus 2 plus 1 plus c2. That means y equal to minus c1 x plus c2. Now put the initial condition here y half equal to 1 and y1 equal to 2. By putting the value y half equal to minus c1 over half plus c2, and that imply this is equal to minus 2c1 plus c2 equal to 1. Then next condition y1 equal to 2, that imply minus c1 plus c2 equal to 2. Calculate, I will get c1 equal to 1 and c2 equal to 3. Just put the value c1 and c2 in this equation. Then this would be y equal to minus 1 over x plus 3. This is the extremal of this functional. I hope my all viewers have understood this type of question. Okay? Well, next equation I yx equal to integration 0 to 1 x sin y plus cos y dx. This is equal to f of x comma y prime with initial condition y0 equal to 0 and y1 equal to pi over 2. Notice the equation. Here f is independent of y prime. And since f is independent of y prime, that means the equation, Euler equation is del f del y dash equal to 0. And since del f del y dash equal to 0, therefore our given Euler equation only, del f del y equal to 0. And del f del y equal to 0 means obviously x cos y minus sin y equal to 0, that imply x equal to tan y, and that imply y equal to tan inverse x, and extremal of this equation. But y equal to tan inverse x be the extremal of this equation when this satisfy the boundary condition y0 equal to 0 and y1 equal to pi over 2. Notice y0 means tan inverse 0 equal to pi over 2 and y1 means tan inverse 1. This value is pi over 4. So this does not satisfy the boundary condition. So since this equation not satisfy the boundary condition, that means this is not be extremal of this functional. I hope my all viewers have understood till now. Okay? Well, our next equation, I will see some example, some shortcut trick to find extremal of the calculus of variation, because I have told you many times calculus of variation actually very important for any competitive exam. So now I will tell you some shortcut rule of calculus of variation. Okay? Well, let's see some example of calculus of variation, and I will say some shortcut trick to find extremal of this calculus of variation. Consider the functional jy equal to integration f of x comma y prime dx, where this functional is y prime plus y. For admissible function of y, then this functional j has option 1 no extremal, option 2 several extremal, option 3 y equal to e to the power of x, e to the power minus x as an extremal, option 4 yx equal to constant as extremal. For this, here f of x comma y prime equal to y prime plus y, then del f del y equal to 1 and ddx of del f del prime equal to ddx of 1, this is equal to 0. Therefore, del f del y minus ddx of del f del y prime equal to 0 imply del f del y equal to ddx of del f del y prime, that means 1 equal to 0. This is not possible. So there exists no extremal. I hope my all viewers have understood. In the equation, the extremal of this functional jy, which is integration 0 to 1 to y prime whole square plus xy dx, with the initial condition y0 equal to 0 and y1 equal to 1, and y belongs to C2 0 1, the solution is y equal to x square over 2 plus 11x over 2. Option 2 y equal to x cube over 3 plus 2x square over 3. Option 3 y equal to x square over 7 plus 6x over 7. and option 4 y equal to x এর cube over 24 plus 23x over 24. Which of the following be the extremal? Here I have seen one shortcut trick. The Euler equation is del f del y minus ddx of del f del y prime equal to 0. Del f del y means obviously x minus ddx of 4y prime equal to 0. That imply x minus 4y double prime equal to 0. That imply y double dash equal to x to the power 4. Since I have told you I will use shortcut trick to find the extremal, here the given in the question has given which of the following be extremal. Here I have got y double dash equal to x to the power 4. For this, if we derivative this y prime and then this would be 2x x plus 11 over 2 and y double prime would be y double prime not equal to x to the power 4. So this is be the wrong option. Similarly, if we second option y prime equal to 3x square over 2 plus 4x over 3 and y double prime does not equal to x to the power 4 x over 4. So this option also wrong option. Third, y equal to x square over 7 plus 6x over 7. Then y prime equal to 2x over 7 plus 6 over 7. This is also wrong. And fourth, y prime equal to 3x square over 24 plus 23 over 24 and y double prime would be 6x over 24 and this is equal to actually x over 4. So only option 4 is the right option. I hope my all viewers have understood the shortcut trick. What is the shortcut trick to find the extremal? Okay. Example OL. The extremal of the following functional integration 0 to 1 alpha t xt plus x prime t whole square dt where alpha not equal to 0 with the initial condition x0 equal to 1 and x prime 0 equal to 0. The extremal of the functional is option 1 alpha over 12 t cube plus 1, option 2 t cube plus alpha t square plus 2, option 3 t square plus t plus 1 and option 4 t to the power 4 plus alpha t square plus 1. For this, here the Euler equation is del f del x. Since here the variable is t, so this would be minus ddt del f del x dash equal to 0. And del f del x is alpha t minus ddt of del f del x dash mean 2x dash. That imply alpha t minus 2x double dash equal to 0. That imply 2x double dash equal to alpha t. That means x double dash equal to alpha t over 2. Use this shortcut method. Here the option is this. You can verify x double prime. Then you will see only this would be satisfy x double prime equal to alpha t over 2, other does not be satisfied. Or you can find the extremal. Here the extremal is, if you want to find the extremal, this is also easy method. X double prime equal to alpha t over 2, that imply obviously x prime equal to alpha t square over 4 plus c1. Since x prime 0 equal to 0, that means that implies c1 equal to 0. So x prime equal to alpha t square over 4. Then x would be x equal to alpha t cube over 12 plus c2. Now apply the initial condition x0 equal to 1, then you will get c2 equal to 1. That means the extremal of this functional is x equal to alpha t cube over 12 plus 1. That means option 1 is the right option. I hope my all viewers have understood this is okay. Well, now I will see one question which had come CSIR net June 2017 exam. The question is the infimum of the integration u prime t whole square dt on the class of function where obviously this u be the C101, that means this u be the defined on C01 and obviously this class of function satisfy the first derivative, and the initial condition is u0 equal to 1 and maximum of 0 1 mod u equal to 1. Notice here we have to find the infimum value, that means we have to find the value of this integration. Here f of x u dash equal to integration 0 to 1, sorry, here u prime t whole square. Obviously this is the independent of, here not x, here t variable is t, independent of t, u and u dash. Now use the Euler equation, then the solution would be equal to C1t plus C2. Here the initial condition u0 equal to 1. That means obviously since u0 equal to 1, C2 equal to 1, sorry, here one printing mistake, u0 equal to 0. That means this implies C2 equal to 0. So the solution is ut equal to C1t. I hope my all viewers have understood how look like the extremal. ut equal to C1t, that means this is actually look like y equal to mx. This is look like the equation of line equation which passes through origin, and other condition given maximum value on the closed interval 0 1 modulus of u equal to 1. Since modulus of u, that means here only taken this part, and since defined on the interval closed 0 1, in this interval here the maximum value is 1, and that means other initial condition is u1 equal to 1, and when u1 equal to 1, then I will get c1 equal to 1. So extremal of this equation would be ut equal to t. Okay, but here the question, find the infimum value. Now put here integration 0 to 1 u prime t whole square dt, that means here ut equal to t, integration 0 to 1 u prime t means obviously 1 dt, then this would whole square, this would be obviously 1, then this value would be integration 0 to 1 dt, and this value would be obviously 1. So the option given, this value is equal to 0, half, 1, option 4 given 2, only option 3 would be right option. This value would be equal to 1. This infimum value is equal to 1. I hope my all viewers have understood. We will stop here. In my next video, I will discuss this type of question briefly, because I have told you this type of example actually very important for higher study. Okay. See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.